Hello students, let's start our lecture number 4. In the last lecture we discussed about the collections in C Sharp, and then we also discussed what is meant by the generic. Today we will be talking about generic collections in C Sharp which are already present in the C Sharp libraries, and then we can just off the shelf we can use them. We will also talk about a dictionary that is also a kind of a generic collection, and then we talk about the file input and output. The first thing is indexes. When we have the arrays, and then we have an index value 0 1 2 3, that's an integer value, and then we can access a specific element that is actually an indexer which has been implemented on that particular specific array. So we can also change that particular specific behavior by using the indexer or implementing the indexer in our own class or the structure. So allow the instance of a class or a structure to be indexed just like arrays. Index value can be set or retrieved without explicitly specifying or type or instance of the instance member as a property expect as same as property expect that it's defined with this keyword with the square brackets and the parameters. So what is that mean? So let's talk about, so we are talking about a class. We say my indexer, and that's a class name, and then we are saying that it is a generic, and then we say private t, and we are having an array in that particular generic array in that particular specific class. And now we are defining a indexer on this particular specific array, that how we can index, how we can access the elements of that particular array. So we are saying that public t this. Now we are not defining anything, like there is no like that's a return type that is going to be returned, but there is no method name. We only say this, and then we say int index. So we are providing in the brackets some integer value, and then we can get that particular specific index. So again, of course, we are going into that my array, and then we are, if we say we want to get the value, we want to return that particular value, we want to access that particular specific value, that go into that my array and it return that specific index value over there. Or if we want to set, then whatever the value is coming, it will be assigned to that particular index value, index position at that particular in that particular my array. So now we are having my indexer, and we are initializing that we have total 100 elements in this one, okay, and then we say that we have defined the get and set methods, and here we are using that particular specific indexer. So we are say we are trying to create an array of strings, my indexer string, because when you say string, it means that all these t values will be replaced with this string. It means that this particular specific my array will be a string type. So we say string, and then my indexer 0 is equal to index 0, and then we try to print something on the console 0, it will print me index 0, okay. So that's what is going to happen here. So indexer, making loops on the indexer to access all the elements in the class. So we can make the like loop to access all the elements in that particular specific array that we have defined. So if we say int I is equal to 0, my indexer dot get length, so we are getting the my indexer, and then we are getting dot length, so it will give me the length of that particular specific array list which is present in there, and then say I plus plus my indexer I is equal to index value at this particular specific index, and then we get the value, so we can access all the elements just like we are using for the array, okay. And here my indexer dot get length, it will give me the length of that particular my array which I have defined in that particular specific class. Override indexer, so we can say that public class string data store, so we have a string, and then we say private, and then we say that we have a string with the 10 elements inside it, and then of course we have a dict error, so that's a default constructor. We define it or not, it's already always there, and it's better that you don't define it. And then we say that we have an index. So when we say that index, and then we have the provide the value, and then we say that we are not only the we get mean, it get mean that we are accessing the value what is at that specific index value is this, and now we are applying certain principles on it, how we can get the values. If index value is less than 0, okay, if that is an index value less than 0, it means it's negative value. No, it's not acceptable, so if you throw an index out of bound exception, or and the index is greater than or equal to the string dot length. If it is less than the 0 or it is greater than or equal to the length of the array, then definitely it is out of the bound, so we can just simply say cannot store more than 10 objects. Okay, so we are providing certain specific we are throwing a specific exception and giving some informations about that particular specific array can only hold the 10 values, so you can't store more than 10. Normally we don't give the negative index, but we always give a positive index, so it is a possibility that we could go out of the range of the 10. If it is not the case, then we are just going to return the string index value, whatever that index is coming in. And the same is for the set value. Again, if we are less than 0 or the greater than the length of the index value, we throw that particular specific exception, otherwise we are assigning that. This is the first, this is the simplest indexer. We are just putting some constraints that we are just checking that that particular index value is not out of the limit in that particular specific array. The second is, now we are saying this, and then now we are not putting the index value as an integer value, rather than we are saying the string name, and then we get for each string str in the str, for every string which is present in our array, we are just comparing those values which are coming as an parameter and the value that is coming from the string array. We are comparing them together. If they are equal, then we are saying that return string, otherwise you just return null. It means that particular specific name or the element that you are looking for in that particular specific string array, it does not present in the string array. Okay, so if it is null value, it is not present, and if it is return some string, it means it is present over there. Expression bodies. So we also have a lambda arrow started in the C#6 only with methods, and then from C#7 we can use them with the properties as well. So this is a lambda expressions which are present, started from the C# version 6 and onward. They have been introduced. They will, it is nothing, it is just a new expression which help us to short the code or precise the code. But definitely when we shorten the code, we are trying to reduce the size of the code, then it is also become a little bit cumbersome. It is not become simple to understand quickly. If you are not an expert in the lambda expression, then it will be like, okay, what's here, what that statement means. We need to, unless and until you become a lambda expression expert, so you have experience with that, then you can easily deduce that particular specific thing. But otherwise it is a problematic to understanding the code if you are not familiar much with the lambda expressions or lambda arrows. So consider that here we are saying that if we look at that here in this one, so we are saying get return this fang, but here we are saying that we say get arrow instead of that brackets, and then we say my array index. It means that we are returning that we have removed the brackets, we have removed the return keyword, and it is going to return value. And here we are saying that set a lambda arrow array index is equal to value. So again, that's something which becomes very simple to write in 2 lines rather than having the multiple lines of the code. But definitely if you are not familiar with this particular lambda expression on the lambda arrow, then it will be like, what does it mean, so we need to understand. So that these are the some what you can say is the pros and cons of that particular lambda expression or lambda bodies. Lambda arrow, even like we have defined a sum which is in int a and b. If you look at that, this particular specific part is exactly the same as our method, normal method, but after that we have a lambda expression or lambda arrow, and then we say a plus b. It means that it will add this a and b and it will return the value this. So we need to understand what does it mean, and then we try to use it, we can get the value quite quickly. Okay. I think that let's code it. not necessary here right now. um, List T. So again, now we will talk about the generic collections which are present in the C#. The first one is the list T. It is same as array list, except that list T is generic and the array list is not a generic. Resize automatically as it grows, accessed by the index value. We can like define something that it's list int, that's a variable name, int list is equal to new list int. It means that we are defining an int list variable of the array list type, but it always contains the integer values inside it. Again, we have the same items, gets or sets the elements at a specific index value at items. Count is more like returns the total number of the elements which are present. That is same as for the array list. We have add, clear, contains, insert, remove, add. They have exactly the same meaning, except that we are talking about the generic type rather than the elements in that particular array list. So this is a list which is a generic type, so whatever that particular element is, it will be removed or add or clear and contains. We can get all those values over there. For the list, again, access list elements, again we can use the what you can say that the index value, because it is just like an array, but as I told you that list is an array but a dynamic array, because its elements can grow and shrink. The size can grow and shrink based on the requirements. So index is 0, I is less than the number of element in that particular list, and then I plus plus, and then we can access each and every element starting from the 0 index, 1 index, 2 index, 3 index, how many elements are there. Accordingly we can also use the for each, because all the collections are implementing the I enumerable, so we can have that int list dot for each. It means that then for each element a list integer value, that's the name of the variable, and it is going to do what we have a lambda expression console.write. It will perform that particular specific print that specific list value which is present in this int list on the console. Okay, so this is and then we can also have int list dot for each, and then we say that list, if we have multiple multiple elements, then even in the lambda expression we need to put that particular specific bracket. So here we are performing three different operations. So we say console.write, we are printing that particular specific integer value. Then we say list multiply by 2, we are multiplying that particular element with that 2 and saving in the list integer value, and then we are printing that particular things again. So if we have a lambda expression and if we have only one statement, then we can just simply write it in that line. Otherwise we have to put the brackets so that we can put the multiple line of code in that particular lambda expression. Okay, so lambda expression, we are trying to understand the lambda expression as well. We need the brackets if we have multiple with the lambda expression. If we have multiple line of code that we want to execute, then we have to put that particular brackets. Again, here we say that int list for each, and then we say print is a method that we have static void print, which take the integer value a. So automatically for every element which is present in this A list, it will be provided as a argument to that print method, and then print method will print that particular specific thing on the console. Okay, we can also have delegate int number console.write number. So again, this is we call them, these are the methods which are without any name. Here we have a method name, but here we don't have any method. We call anonymous methods. They don't have any name for that. So that is also a possibility that we can use in the C#. We also have a sorted list. In the sorted list, again we have a key and we have a value pair. Again, these are the generic types, and they become the generic values, and then we can assign them different values when we are defining that particular sorted list. So covered in the previous, sorted list we have covered in the previous lecture. So store key value pairs in the ascending order of the key by default. Key can be null, key cannot be null. The key value cannot be null, but the value itself can be a null value, because we are sorting the things. So key has to be provided rather than the value can be a null, but key need to be provided whenever we are adding a new element in that particular sorted list. We have different methods: capacity, count, keys, and values. Keys and values. Keys will give me the what you can say, that list of keys or array of keys which are present in that particular sorted list, and the values will give me the array of the values which are present in that particular specific sorted list. We also have add, remove, add, contain key. All these methods are present, which we have, I have explained those things in the previous code as well. We also have dictionary. Dictionary is also a key value pair, but here the values are not sorted based on the key. Okay, so key value pair, keys cannot be null on or duplicate, but values can be duplicated or can be null values. So keys are the things that will help us in the sorted list. They will help us sort the elements, and then here the keys will have in this dictionary will help us to identify a specific value. So these keys cannot be null or they cannot be duplicate value. It is if you are more familiar with the database, so you can say it is a primary key. It has to be provided, it has to be unique, and on the other hand, the values can be null and values can be duplicate, but these keys can't. So again, we have the count method, which give us the total number of elements which are present in the dictionary. Keys will give us the list of the keys, values will give us the list of values or the array of the values, and item gets or set the element at a specific key in the dictionary. So if we in the item method, we are saying that go to that particular key value and then change the value with the new value itself. Okay, so sorted dictionary, again, this is it is also a dictionary, but all the a collection of key value pairs that are sorted based on the key. Okay, so if we try to talk about the efficiency or the time consumption, how much time they need to perform some specific methods. Sorted list is actually O1, indexed looked up. We look up at that specific index. We can do it in the constant number of times. It's something like that. We know the index value, code that index value, and do the things. So it is something like constant time is required to look up a specific index. In the dictionary, there is no index lookup, because we are based on the key. We are trying to find out the elements. Keyed lookup, we can take long, and if we are looking for a specific key in the sorted list or in the sorted dictionary, we have to find out, we have to traverse from the first element to the last element. So if we have n elements, okay, then we can try to find out that log of n. I think this is something which is out of the scope of this course, so let me go to the next. It's more like we are trying to find out the time efficiency of that particular specific element, okay, or specific data structures, how efficient that particular specific data structure is. If it is log n and the on, we can say that these operations are efficient. But if we say on square or ox a raised to power n exponential kind of things, then we say that they are not. So if we look at that, we have on or log n. So it means that we can say that these two, sorted list and the sorted dictionary, they have what you can say that they have a very efficient methods which can be produced, addition, removal, and lookup, and key value lookup, and the key lookup or the value lookup. They are very efficient methods. But the one thing that we want to see here, if we look at the sorted list, it take a lesser memory or less storage area inside our RAM. On the other hand, the sorted dictionary, it take a greater. So that could be a concern if we are talking about a sorted list or the sorted dictionary which are containing millions of entries. It means that this sorted list will take less amount of memory in the RAM as compared to the sorted dictionary. So that's really considerable consideration when we want to decide that we want to go for the sorted list as an implementation or implementing our data structure, or we are want to use sorted dictionary for our data, so saving the data in our program. So that will be a reasonable consideration. Okay. But on the other hand, if you look at that, the operations, the sorted list is on most of the time, but here sorted dictionary will give you the quick time to do some operations. So again, we need to find out, we want to save the RAM or memory, or we want to save over time when we are performing something specific operations on it. Similarly, in the generic collections, we also have the stack and the queues, which are generic. You can go into those links and then you can see that the operations are exactly the same, except that type is generic. Okay. So that is the end of our what you can say that generic collection discussion. So next we will be talking about the file input and output. So if you want to go into more detailed information on that particular specific topic, you click on that link and then you can go into that one. But here I will say it was iterate through our directory. File IO, we have a file class which is present, or file library, IO library, which is present in the C#. In that file library we have the file class, and the file class can represent a directory, it can represent a file. So how we can, so first of all we are trying to find out if we want to look from how many drives we have, a C drive, D drive, or E drive. We have 3 or 4 drives in our program, in our computer, and then we want to access each and every element inside this one. How we can do that? The first thing is we can get the drives from our system, in our system, not out system. Okay, so let me what you can see that quickly remove that particular specific out to R, and yeah, so we are back. Okay, so in our system, okay, in our system we have the drives. So we say string drives is equal to system.environment.get logical drives. So we have a system library. In the system we have the environment library, and in the environment library, in environment class, we are having the get logical drives. And you know that this particular method, that's a get logical drive, must be static, because we are not creating the object of environment class. Rather than we go just telling that in the systems library we have the environment class, in the environment class we have a static method get logical drives, and we are using that without creating the object. So static methods can be accessed, and we have discussed that in our lecture number 2. Getting info for each logical drive and root. So again we are saying a drive info, we are getting the drive info from those drives. We have the DR, that is logical drive, so we have DR. Okay, and then we say directory, root directory is equal to DI, that is our drive information. So we say drive dot DI dot root directory, it will give me the root directory, the C column or the D column or the E column, whatever, that root directory which contain everything inside it. That is we get those things. And then first of all we are asking, we get the file info, files, and then we have a subdirectory. Actually we get the root directory from our main method, and then we are trying to say that we are try root dot get files, it will give me all the files. And then we can see that the other thing that we are doing here, for each file info, we are saying that give me write some information about that full name, file name. Okay, and then we are getting the subdirectories here. So we are saying that subdirectories is equal to root dot get directories. If they have multiple directories in that particular root folder, it will give me all. And then here we are doing the recursion. So we are saying walk directory tree, and we are giving the drive information that is coming as input to this one. So if we have multiple directories in this, we are doing the recursion, and again go into that particular specific directory, again look at the files, print them all files, and then get all the subdirectories and so on. So in this way, using the recursion, we are going through all the directory which are present in the root directory, and then go to subdirectory to the last level, and then we can print, we can traverse, we can print all the files which are present in the our program in our computer. And definitely this is not a good idea. Yes, you can say that I want to start with a specific directory which has a very limited amount of information for the testing purposes, and then you can try to get that particular specific, open that particular specific directory, and then you can traverse down. So that is an idea. But if you start looking for the whole computer, that how many files are there, then I would say that don't do that, because it will take a long time to finish that particular specific program. Okay, so this, in this way we can look at the directory and the subdirectory and all the content which are present in that particular specific, whichever the starting point is. We also have, of course, when we talk about the file input and output, it means that we are reading from file, we are writing in the file. So first of all, we are checking that how we can write a file. So if we look at that, we have a system.io.file, that is a file class which is present in the IO library, in the systems library, and then we also have a stream reader which help us to write the files on it. So text or the contents of a file, open a file, and then write a. First of all, we need to decide that what we want to write in that file. Then we open a file, and then we write that particular in file and close that file. So if we try to look into that one, first of all, we are creating the text that we want to write in the file, and then we are opening a stream reader. Stream reader is a simplest way to do the things. Actually, what is happening in the background, that particular specific stream writer help a stream writer open a file with the name write text.txt, of course in the current directory, current working directory that where you are, and then for each string in the line, so for every string which is present in this lines array, string array, we are writing that particular specific, and then we say that async mean that we are making it a thread. So and that async, and then we say await, it means that it will write all the lines inside the file, and then it will return us back that task, and then we can look at the task. The task is in the running state, task is in the finished state. If it is a finished state, we can close that particular specific, we know that that particular writing task has been done. So this is also how we can implement the what you can say that in the threading inside our C#. Again, we also have another way. We have created the text, and then here we say file.write all lines async. Here we are saying that we have in the system.io.file, and that in the file class we have a static method which is the write all lines asynchronously, and then write lines, we are saying that open that particular specific file, write these lines in that particular file. So this is also possible. Okay, so we have different ways, whether we use the static method in the file or we use the stream writer that help us to write line by line. It will give us more control. We can apply certain specific constraints that which line need to be written and which line don't need to be written, and so on. But we also have the other way. So I mean, there is not one way to write a file or create a file. That right now we are talking about a text file. We can also want we may also want to work with the image files or the video files, or maybe the Excel files or the document files or some other type of files. So how we can, so there are multiple ways to write into the files. Okay, then we also have the append. We want to append to a file. So we have, if you look at that, we have first line, second line, third line, fourth line, because we are using the same file that we have created earlier. So it will say Now we are saying that fifth line, sixth line, the new lines we have created, okay, and then in the new lines we are saying stream writer files equal to new stream writer, and then we have a specific append parameter which is we are saying true. It means that it will open that particular specific file, but it will not overwrite. If we don't have the append is equal to true or append parameter as a true, what will happen? If it will try to open that particular specific file. If it already exists, it will overwrite the contents that we want to write there. But if we say append is equal to true, it means that open that file and it will not overwrite, it will keep the contents of that file, and the new lines will be added at the end of the file itself. So append, so we can do the append, the same method that we are using, and then we are opening the file. So here we have different methods which are present in the file class. We also have open, string, and file mode. File mode mean that in which specific mode we want to open that file. Create new, it means that if there already exists that particular specific name of the file and you want to create a new, it will give you it will throw you a exception. If you say create, if already existed file, it will overwrite the previous one. Open mean that you want to open it and you don't want to create it or start. If it does not exist, that particular file name that you give the open read, open write, open string, you are giving the file name. If that file name does not exist in the current directory, it will say sorry, we can't open it because that particular file does not exist over there. And if it is already there, then it will open that particular space. Open or create, it means that either if that particular file exists in the current directory, okay, open it. If it does not, you create that particular file. And truncate mean that you want to open it and all the what you can say that all the contents which are already present in the file, you just delete them. Truncate, open, truncate. I'm opening it, but we are truncating all the contents in that particular specific file. Append, of course, open the existing file and append the values at the end. So we have file modes which has been defined in the file class, and then we have open read, open write, write all bytes, read all bytes, read all lines, write all bytes, write all lines. And look at that, all these methods are starting with the capital letters. So when they are starting with the capital, they are the methods, so it means they are the static method which are present in the file class, and we can use them without creating the file object. Reading from a file, so how we can read? Again, we can, using the file class, we have the read all lines method, and that can help us to read from a specific file name that we have write text or txt, which open that file and read all the lines and give us the lines as a return. And then we are trying to print those lines on the console to see that what we have read from the file. Again, we can read using the read all text, rather than making a thread, making a thread, multi-threading part. We can use read all lines without the async. So that is a normal. It means that we have to wait unless and until that particular specific text has been written. So read all text, it will read all the text which is present in that particular text file. And then we said read.console, we are writing those text on the screen so that we see that what we have read from the line. And then we have the second method, read all lines. It will read all the lines and give us the array of string, which each element of the array will contain the line or in that particular specific text file, and then we are printing them on the console. Then we can also have the stream reader. Rather than using the static methods of the file class, we can also use the stream reader. Again, it is doing the same thing rather than, so here we are saying that reader we are reading line by line rather than reading all the line and reading all the text and so on. So here we have, so we also have the multiple ways to read from a file. And again, if that particular file is of the different type, like it's an image or maybe some other video or a document file or the Excel file, so then we may need to have a different way to read. So we have multiple ways to read from the file. We have a stream reader. If you click on that link, you can go into the documentation part, and that is the reference for this lecture. And I hope you have enjoyed this lecture. Thank you very much.